everybody. Welcome back to our second of three examples with reciprocal functions. We're going to go into something a little bit more difficult now. If f of x is equal to a quadratic, if f of x is equal to x squared plus 2x, graph the reciprocal. So I guess we need to start off with graphing f of x is equal to x squared plus 2. Press pause and graph it. Hopefully you've done that. And I would encourage you now to, here's what I've done, is I've looked at these x values. Ask yourself, why would I look at these x values? Additionally, ask yourself, what are the y values that go along with this x value? Press pause. Try to figure it out. Oh, welcome back for joining us. Anyways, I think that I got the x value or y values correct. So instead, I could graph my function here, right? Here's the graph of my function. Certainly hoping it's correct. Now, I could use a table of values to graph the reciprocal function, or I could graph it straight off the graph itself. I just have to recognize that for every point x, y, when we take the reciprocal transformation, that's what it will look like. So if you want, this is what my transform table of values look like. I'm not going to spend any time on this. Instead, I'm going to try to transform it straight from the graph. Now remember, when I look at a point, when I take a look at a point here, when I transform it, pardon me, I just simply take the reciprocal of the y value. So let me start off. I've always found the best tool when doing transformation is a pen to point to a point. I'm going to transform this point. How? Well, this point looks like it's -3, 3. So the x value stays the same. The y value is 3. So when I take the reciprocal of the y value, it turns it into a third. There we have it. Okay. I've done one point, but let's get a great look at this graph. I know that whenever my function f of x, and that's this parabola, has an x-intercept or a 0, that turns into a vertical asymptote. I know I have a vertical asymptote here, and I notice also I have a vertical asymptote along the y-axis here, because it is also a 0 of a function, or it's also in an x-intercept. Also, all reciprocal functions have a horizontal asymptote at y is equal to 0. So I have my asymptotes, which are basically the guidelines for graphing. But the free gifts don't stop there with reciprocal functions. Now, here's a weird point. This one right here. This is called a stationary point. What is the x value of that stationary point? I have no idea. I guess I could figure it out, but I don't want to. Simply because at this specific point, since the y value is 1, when I take the reciprocal, the y value is going to remain as 1. This is called the stationary point. So wherever the y values are 1, you can just simply put a dot. These two stationary points represent points that are common to both graphs. Similarly, at -1, if I have point x comma -1, when I take the reciprocal, it's going to go to x comma -1. There. I guess we've seen this with here and here, haven't we? All right. Now, I'm not going to look at this table of values. I'm just going to do this. So now I'm going to ask myself, now this is a clever argument. On this side of the asymptote, I notice that my y values are positive but small for f of x. So when I take the reciprocal, they turn into large positives. So for instance, I don't know, this is going to be 0.1, positive 0.1. So when you take the reciprocal, it turns into 10. And that follows the asymptotic behavior, doesn't it? Now, we know that this graph will look like this. So I've graphed exactly one arm of it. Now, alternatively, let's go to the middle area. I'm going to take this point, very close to my asymptote. I notice that my y value is small and negative. Now, you could say negative quarter. So x comma negative quarter, when you take the reciprocal of the y values, that negative quarter turns into 4, or something very large. So what I know is that my graph will open like that. Now over here, I take a look, what is my y value? My y value is negative quarter again. So when you take your reciprocal, it goes down here, right? Now it doesn't need to be negative quarter, it could be negative tenth, but still you're going to have a parabola, oh, sorry, not a parabola, but a parabola shape in the middle, won't you? That's opening downward, that approaches the asymptotes. On the third domain of this graph, what we see is I'm going to take this point right here. Now on this side of the asymptote, my y value is my y value is 0.1, we'll say, or small positive. So that when I'm applying, so if xy is on f of x, point x comma 1 over y is on the reciprocal. So if I imagine this point is negative 0.1 or negative tenth, when I take the reciprocal, it just gets large, positive. Now if you notice, this is an imaginary point. It's a symbolic point. But it still definitely works with our argument. We just have to make sure that we observe asymptotic behavior. So last point to transform is 1 comma 3. 1 comma 3 turns into 1 comma 1/3. Now we have to approach the horizontal asymptotes. Now here, only the left hand and right hand side are affected by asymptotic behavior. What we see is the function approaches the asymptotes, but do not touch. I hope this helps out. I know this is fairly abstract reasoning, and we're just dealing with transformations. If you have any questions, please read.